Hello, everyone. My name is Brennen McManus, and today I'll be presenting the research I did in the biosciences group under Dr. Klinich. And the topic of this presentation is a postural comparison between individuals seated in wheelchairs and standard automotive posture. This research topic is of special interest to autonomous vehicle manufacturers, as individuals with disabilities related to mobility will be one of the largest beneficiaries of autonomous vehicle propagation, and it is important that we study the postural differences between the two groups to ensure a similar level of safety for all occupants. And in order to do this, we need to accomplish two main objectives. One, we need to collect representative point cloud data demonstrating the seated posture a wheelchair occupant is most likely to use in an AV if they could remain in their wheelchair. And two, we need to obtain postural measures from our data that allow us to compare the posture of wheelchair users to standard automotive posture. The methodology followed in the study can be broken into three subcategories: data collection, avatar generation, and data analysis. The data used in the study is a mixture of point cloud data from past UMTRI studies and new data collected specifically for this study, totaling the 49 volunteers with ages spanning from 18 to 90 and BMI spanning from 18 to 55.7. In our most recent data collection, we used 3 Kinect Azure sensors, along with software provided by Dr. Park, to obtain point cloud data representative of an individual's posture. Next, I generated baseline avatars in standard automotive posture using additionally collected parameters with help from humanshape.org tools and additional software created by Dr. Park and Dr. Reed. And I was then able to overlay the 3D point cloud data on top of the respective baseline avatar and adjust the lengths and orientations of body segments to match the posture of the point cloud data, which provides us with a collection of adjusted avatars that match the posture of our volunteers. With this collection, I was then able to use the landmarks outlined in a past work by Dr. Reed to calculate similar postural angles to those laid out in that same work. And from this data, I was able to compare the mean values of baseline and adjusted avatar angles and also evaluate postural angles as a function of various qualities of the population. And the resulting data from this analysis highlighted several key postural differences between the angles of the baseline and adjusted avatars. As shown in this table under the middle results column, statistically significant differences in head, neck, abdomen, thigh, and hip eye angles were present. And we can see that this data point toward the prevalence of wheelchair users adopting a more reclined torso posture with a more forward head and neck angle to compensate. If I zoom into this figure here, we can see that the red lines F5, M15, M95 represent the 5th percentile female, 50th percentile male, and 95th percentile male dimensions. And the blue and gray lines represent the posture of our male and female volunteers respectively. And we can very clearly see this postural trend that I just mentioned. We were also able to observe statistically significant differences within the subgroups of our volunteer sample. The most notable differences in posture existed within BMI strata. Specifically, as the BMI increased within the wheelchair sample, we saw a greater deviation from standard automotive posture, in the sense that individuals with higher BMIs were found to more extremely exemplify reclined posture than their counterparts. In this table in the right column of results, we can see all of the statistically significant differences. So the current data collected demonstrates several significant areas of postural deviation between standard automotive posture and the posture adopted by our sample of wheelchair users. And as the study continues, we hope to gather more data that can be used to differentiate between the posture of individuals in their wheelchair and standard automotive posture. Thank you everyone for listening.